Physics Part 228. We've got the section summary. Free oscillations are oscillations where there are no resistive forces acting on the oscillating system. Damping is produced by resistive forces which dissipate the energy of the vibrating system. Light damping causes the amplitude of the vibration of the oscillation to decrease gradually. Critical damping causes the displacement to be reduced to zero in the shortest time possible. Without any oscillation of the object, the overdamping also causes an exponential reduction in the displacement, but over a greater time than for the critical damping. The natural frequency of vibration of an object is frequency at which the object will vibrate when allowed to do so freely. Forced oscillations occur when a periodic driving force is applied to a system which is capable of vibration. Resonance occurs when the driving frequency on the system is equal to its natural frequency of vibration. The amplitude of the vibration is a maximum at resonant frequency. Section questions. The apparatus of the figure is used to demonstrate forced vibrations and resonance. A 50-gram mass is suspended from the spring, which has a spring constant of 7.9 newtons per meter. A. Calculate the resonant frequency of F0 of the system. B. A student suggests that the resonance should be also observed at a frequency of 2F0. Discuss this suggestion. We've got a few exam-style questions for this section. Number 1, all bodies moving in a circle experience centripetal acceleration. E. What does this centripetal mean? Explain how centripetal acceleration arises. 1b. The moon's orbit around the Earth may be assumed to be circular, with radius 3.84 into 10 power raised to 5 kilometer. The moon moves the constant speed in the orbit, takes 27.3 days to complete one orbit. Calculate the magnitude of the centripetal acceleration of the moon. A bicycle is set up on a test rig with its front wheel clamped and its rear wheel resting on a roller. The pedals are turned so that if the bicycle had been free, it would have been traveling at a speed of 8.3 meters per second. The outside diameter of each tire is 0.66 meter. So calculate the angular velocity of the rear wheel of the bicycle. Calculate how many times per second the rear wheel rotates. B. A small pebble of mass 4.0 gram is embedded in the tread of the rear tire. Calculate the magnitude and the direction of the force needed to keep the pebble in circular motion. This force is equal to the maximum functional force. This force is equal to the maximum frictional force that the tire can exert on the pebble. Describe and explain what happens when the rear wheel is rotated at a faster rate. Number 3. 3a. Define simple harmonic motion. 3b. Figure illustrates a U-tube of the uniform cross-sectional area E containing liquid of density P. The total length of the liquid column is L when the liquid is displaced by an amount of delta x from its equilibrium position.